Hi friends, right, let's get started. In this video, I'm going to be talking about some computer science tips which you can use. Now, the first thing is that I think the biggest issue with beginners is motivation. I think we start to give up on a problem when we fail too many times on that problem. I've experienced this many times. I've tried to solve one problem, but by solving one problem, other problems started to occur, and by just having all of these problems and you're failing so many times, you just start to give up, which is completely normal. But just remember that programming is not difficult to learn, but essentially it just takes time to have a proper grasp on everything. So making mistakes and failing in problems is completely normal, and it's part of the journey. Everyone makes mistakes while programming, so don't get discouraged when you fail. And if something doesn't work, that is completely normal. The only way to overcome problems is to first research about a problem and understand why you're actually getting a problem, and then ask questions to other people. So have some friends who are programming and ask them questions why that thing is not working essentially. And the third solution is to try a different approach for the problem. So if something doesn't work, then try another approach and stuff like that. I think programming is not really about intelligence, but it's mainly about exposure to the problems. If you're confused about a problem, just remember that exposure to the problem is the best cure for confusion essentially. So I think anyone can actually be good in computer science. The more we practice on a problem, the better we become essentially. When I first made my tic-tac-toe game, and this was in object-oriented programming, I think this was in year 2 of university. This was the first Java class which I ever had in university. And basically in that class, it took me a long time to actually understand how to make a tic-tac-toe table. So I literally didn't even know how to make a tic-tac-toe table to actually put X and O's in the table. And after a lot of Googling and asking friends, I finally found a Stack Overflow page which basically helped in half of the answer. But this took me days, literally days, to just figure out how to make a simple table in a tic-tac-toe game. And after that class was over and during holidays, I then wanted to make my own game. I made a sort of RPG game, and this game basically allows you to pick a character. So you can pick a knight, you can pick an archer and all that. And basically you pick the character and put them on a table. The game will play by itself. One character will attack the next and the health will decrease and so on. The game ends when one player is left standing essentially, and the player which is left standing basically wins. And that game basically uses the same table which I used in my tic-tac-toe game. I literally just copied and pasted the whole table code in my tic-tac-toe game into my RPG game. And some people wondered how was I actually able to make the table very fast, but I didn't make it very fast. I only made it fast because of the hours that I spent in making the tic-tac-toe game essentially. I think computer science really uses a lot of your creativity essentially. And creativity basically happens when you look at a problem long enough and you have a thought which basically connects all of the dots essentially. And I believe creativity is not a skill or anything like that, and anyone can actually be creative. I think it's part of being human essentially. And just for computer science as well, there are many tough problems and stuff like that. There's a lot of problems which needs you to use your imagination and need you to use your creativity side essentially. And for me, there's many times where in computer science where I basically spend hours trying to figure out a problem, and in the end I just find a thought which basically just fixes everything. So it's not about being smart or anything, it's just taking the time of actually thinking about a problem and basically searching up in Google to find some answers on how to actually solve the problem and stuff like that. It just takes time, that's all. And I think programming is all about hands-on typing code inside your text editor or IDE and stuff like that. But it's all about doing it essentially. And it's also about being consistent. So I think you should be consistent in a specific language until you kind of master it. If you switch languages all the time, it'll just make everything confusing. Programming is all about taking it slowly. Do a question a day and don't be in such a hurry to do everything all the time. And honestly, there's no rush in being good in programming. The main thing that you just try a problem a day or something like that, and that's really fine. You don't have to be in a rush to know everything essentially. And I think for computer science, you should know some theory behind it. For hash maps, you should know how does it actually work and stuff like that. And you should try and understand it and apply it to a real problem essentially. And I think if you just practice on learning hash maps for 5 years on just hash maps alone in just one programming languages, you probably will just be an expert in hash maps. But I wouldn't just suggest you to learn one thing or one algorithm or one data structure for a couple of years, because even in university you're not just going to learn one thing. They're going to teach you a lot of stuff. But what I'm trying to say is that knowledge compounds. So like the more you practice on like the problem and like the more exposure you have of like different problems, the better you'll become, and like your future self can also be grateful to your past self because like you've practiced on so much stuff and like you've been exposed to so many things, so it's much easier to like grasp new concepts essentially. And like you should look back at yourself when you were younger. Like the only thing you could do is just make a hello world program, but like now you have learned more complex stuff. You might have learned like for loops, you might have learned about recursion, you might have learned about stacks, queues, Dijkstra algorithm, all these kinds of stuff essentially, and you are much better. So even when you're having trouble in doing something, just look back. The things which you have learned in the past are basically like peanuts to you right now essentially, and maybe in the future the stuff which you're having problem right now, it will be peanuts to you in the future essentially. Programming just takes time. There's a lot of concepts in programming and all of them just takes time. You might have learned one concept, but in that concept there's tons of problems which can occur, and it just takes time to be exposed to all of those problems essentially. Everything takes time, so don't be discouraged. And I think in programming we have like a lot of resources, like there's LeetCode and like there's other websites which you can use. And I made another video talking about a lot of cool resources which you can use. It's somewhere over there if you want to check it out. And I think like everyone just needs to have like patience and know that like everything will be fine in the end. And like I have this like 37 page PDF, I think, from one of my units in year 3. This was called Informatics Large Practical. And basically in this unit, there's basically no lectures, and essentially they just gave this PDF to do, and in the PDF there are 2 courseworks inside. And it's like a lot of questions inside, and there's a lot of words which I'm just reading in the PDF. And with this 37 page PDF, like there's so many times where I've stumbled into problems, and I just go from like one question to the next essentially. So I look at one question, figure out what function they want me to make. I Google up anything which I'm confused in, and it just takes time for me to actually like think about the process essentially. And like in the end, you are going to find out the answer. Like it just takes time to actually like understand the problem. You might have one problem, and then when you solve that problem, you might end up with another problem. But like in the end, when you solve enough problems, you would understand like how to do that code essentially. So just don't worry. Alright, that's it for this video, and thank you for watching. Goodbye.